What's up, mathematicians? Justin here, and in this video I'd like to talk about the concept of a solution set. So solution sets often come up in the context of solving algebraic equations like the one you can see here on the paper. A solution set is just the set of all numbers that you can plug in for x or replace x with such that those numbers make this equation true. Those numbers preserve the equality of this statement. So in this case, there's only one number that we can plug in here for x that will preserve the equality of this statement. Now, how do we find out what that number is? There are quite a few different ways you could go about this. Depending on who your teacher was or where you learned how to solve algebraic equations, you might have this idea of like, oh, I must follow step 1, step 2, step 3 only in this order, and otherwise no. I disagree with that completely. I think there are many ways to go about this. You could start guessing and checking and see if that gets you there. You could start just sort of analyzing, well, basically when I add 11 to this number, I need to get 65. So thinking about what could go in there such that when you add 11, you get 65. And probably you could solve it in your head doing that. But if you were to sort of follow that regimented step-by-step process, it would probably look like this. The teacher or the textbook or YouTube video, whatever, might say, well, start by doing the addition and subtraction, sort of work through order of operations backward. And so you're going to start by getting rid of this plus 11, and the opposite of adding 11 is subtracting 11. And well, 11 minus 11 is 0, so then I have 6x equals, oops, I messed up there, sorry about that. Got to do the same thing to both sides. That is an important rule, by the way. Always do the same thing to both sides. So 65 minus 11, this is going to give us 54. Okay, now what to do next? Well, x is not yet by itself. We have 6 times x. Well, the opposite of multiplying by 6 would be dividing by 6. So let's divide both sides by 6. 6 divided by 6 is 1. And therefore, those 6's are going to cancel out. And 54 divided by 6 is 9. So there we go. We have our solution to the equation. But what this really means is that the solution set for this equation must contain the number 9. Now in this case, that is the only number that goes into the solution set, because 9 is the only number that I can plug in for x to make that original equation true. Now, this step-by-step process, by the way, is very useful. I'm not saying that you shouldn't use it. I'm not saying that it's not important to know. It is. But I also want to emphasize that whatever way works for you or makes sense to you that gets you to the right answer is fine. I think that you should definitely learn how to use this process, but you should explore other processes and approaches as well. Let's look at another problem that probably will seem a little bit more difficult, at least on the outset. So let's think about this right here. We have x minus 4 squared minus 81 is equal to 0. Okay, so this is a completely different problem. The x here is definitely not the same as the x here. And this is going to have a completely different solution set, most likely. I mean, it's possible it will end up being 9. We'll see. So let's think about this equation here. Well, I need to figure out a number or several numbers that when I plug them in for x will make this equation true. Well, since I'm subtracting by 81 here, whatever I have here must be equal to positive 81, because when I subtract 81, I'm getting 0. So whatever this expression right here is, well, it's got to end up being equal to 81. So let's think about this. Some number minus 4 squared equals 81. Well, if you know your squares, you'll know that 81 is equal to 9 squared. So what mystery number, when I subtract 4 from it, will give me 9. Well, think about this for a moment. You'll probably realize that, oh, 13 minus 4 is equal to 9. So 13 is a number that I can plug in here for x. So let's go over here and I'll put my curly braces. So in the solution set for this equation is 13. We can double check this because if I plug 13 in here, 13 minus 4 is 9. 9 squared is 81. 81 minus 81 is 0. So it works. But are there any other numbers that are part of the solution set for this equation? And in this case, there are. Because when you square a negative number, you get a positive number. So if I can make if I could make whatever is inside this parentheses equal to negative 9 when I square it, I'm going to get positive 81. Subtract 81, I'll get 0. So let's think about this. I want something minus 4 to equal negative 9. What thing, when I subtract 4, will equal negative 9? Well, that is going to be negative 5. Negative 5 minus 4 is negative 9. And if I plug negative 5 in here, you'll see I have negative 9. Square that, gives me positive 81. Subtract 81 will give me 0. So negative 5 is another number that I can plug in for x to make this equation true. In other words, or hence, negative 5 is also part of the solution set for this equation. Now, you might wonder, are there other numbers that could be in the solution set for this equation? And it's not necessarily obvious that there aren't, but I will let you know in this case, these two numbers are the only numbers in the solution set for this equation. All right, that's all for now. Stay tuned for more great math content.